Welcome everyone to the Center for the Blue Economy speaker series. This is also a class for those who are taking a master's in the International Environmental Policy program at the Middlebury Institute. So welcome all the students. And it's also part of the Environmental Justice and Sustainability speaker series started by the students. And very much appreciate that the students started to look back at the past of the environmental movement and start to request that we read a land acknowledgement to acknowledge the first peoples of the Monterey area, which is where we're located. And rather than read the standard land acknowledgement, I'd like to share what I learned last Saturday at a blessing of the butterflies. Pacific Grove is the butterfly town. Every year about 45,000 monarch butterflies will overwinter in the eucalyptus trees there. They had 0 last year for the first time. And so I went to the 14th annual Blessing of the Butterflies. We did see some there, which is great, but also learned the Esselen Nation are the first peoples of this area, the Esselen tribal nation. And that there is also the Rumsen, who pre-Columbian contact came down from the north with their own language. And when the Spanish first arrived and saw them, they were Costeños, but no one could pronounce that. So they all became the Costanoans when the Western settlers got here. So we acknowledge and then that group of people were kind of forced in order to have federal recognition to join with the Ohlone people of the San Francisco. So we acknowledge the Ohlone, Costano, and Esselen Nation as the previously recognized tribe, which fell out of recognition due to administrative oversight in the 1930s. So I would like to ask everyone if you would like to please urge that the Esselen Nation be recognized federally as an independent tribal nation. And there's more that we can do for them. Please contact me and I'll let you know some other things that they have on the docket. So we acknowledge them, and from Saturday, what I received from them was that despite missionization, government changes, broken treaties, devastation to our culture, and loss of homeland, we have survived. We are waking our language and teaching our children and grandchildren. So we honor the first peoples and honor all the students who brought that tradition to us of the land acknowledgement. And one last announcement before I turn it over to the director of the Center for the Blue Economy to announce our speaker. Tonight we have students interpreting. Simultaneous interpretation is available into Chinese and into German. If you would like to use those services, you'll find an interpretation icon on your Zoom toolbar, and you can listen to Dr. Delia in German or in Chinese if you prefer. So with that, I will now turn it to Jason Skorst. Dr. Jason Skorst is the director of the Center for the Blue Economy and the chair of the academic program, the International Environmental Policy Studies program. Jason.
Yeah, so thanks, Rachel, and thanks everybody. Good to be here, and we're very pleased to have Dr. Delia to give us a talk on kind of the overview of the world's deltas, without getting into the details, because I'm sure he will, again, some of the most productive ecosystems and the coastal environments in the world, and also some of the most challenged because they're kind of the recipients of all the kind of, pollution and effluent from all the inland areas. And then, of course, they've been re-engineered and cut, sliced, and diced. And so a lot of going on there. So really looking forward to getting this overview and then a little case studies in our Gulf of Mexico area. So Professor, thank you so much for joining us, and then the floor is yours.
Thank you very much. It's really a pleasure to be able to be here with you. There's something special, I think, about going back and talking at your alma mater. My PhD is from the University of Georgia, and I've had the chance to go back there and talk, and it just feels good. I've been fortunate to be at LSU for 12 and a half years. And I must say, I've learned an awful lot about deltas in that time. And I'm really pleased to be able to share information with you. I would say if there's anything that's unclear as I speak, please feel free to interrupt me and I will try to clarify it. If we can hold most questions though till the end, that would be probably the most efficient way of proceeding so that I don't run out of time.
Yeah, people can post questions in the chat as we go along, and we'll come back to them at the end.
That's perfect. So let's see, I've just got to make the screen advance. That is not happening. Why is that not happening? There it is. Okay, so what I want to cover today are the generic challenges of coasts and deltas. I want to give you an introduction to what sea level means so that you can distinguish the different kinds of sea level rise that we have to deal with. You need to know about what causes deltas to accrete, to grow, or to erode and wash away. You want to learn a little bit about the scope of the delta problem worldwide, the delta problem in the US in specific, with special reference to where I'm from in Louisiana, give you some examples of other deltas in trouble. Now, there are a lot of them, so I can't hit everybody, but I'm going to give you a pretty good list here. And then talk a little bit about what we're doing and what possible pitfalls exist down the line. Now, the first thing that everybody needs to realize is that our oceans are very important to us economically, and our coastal zones are a large part of that economic benefit that we receive. And right now, you're all probably very well aware, we've got a lot of ships outside of the port of Long Beach and LA, ports of Long Beach and LA, and they can't get in, and that's really causing a major bottleneck for our trade issues. But the ocean economy has contributed 350 plus billions to the U.S. Gross domestic product. It supported 3.1 million jobs. This is back in 2014. Carried $1.5 trillion worth of cargo through our seaports. And incidentally, in Louisiana, we have 3 seaports which are not the largest in terms of economic impact. The stuff going through the ports on the West Coast is much more valuable per pound, but we're very important in terms of export to the rest of the world, particularly of grains and things that come out of the Midwest and the wonderful farms we have up the Mississippi River. So we have a very big role, and so we're the largest by volume. We generate a lot of revenue from oil and gas leases. Next to income taxes, I think that the leases provide the U.S. a lot of money in second place. And then the big point I need to make to everybody is that all that is at great risk, and it's at risk because of what I call the triple whammy, which is that we have in the coastal areas threats from the atmosphere, from the land, and from the sea. And any one of these can act up on us and cause us real nightmares. And in Louisiana, we're just 3/4 of the way through hurricane season, and we've had a bad couple of years, let's say, with a couple of category 4 and 5 storms off the coast in the last 2 years. So that's certainly a big problem. And that's a combination of atmosphere and sea working together. We've had problems from the land. We had a couple of years ago a very large freshwater flow down the Mississippi River that literally almost overtopped the levees and could have again flooded New Orleans, and certainly Baton Rouge is even worried at the time. So what goes on up the watershed is really important to us. We have the transport of sediments and nutrients coming from upstream. Both are important, and the arrows show you that the directions we're seeing, sediments are going down and nutrients are going up. So what happens with the nutrients? The nutrients go off the coast of Louisiana and cause big algal blooms. These phytoplankton will eventually die and settle to the bottom, and in the process of decaying, they will cause a hypoxic or low oxygen zone. So that's a big issue for us. And obviously you don't want to have big areas of low oxygen off of your coast if you have a lot of fisheries, which we do. Sediments are important because they are critical to supplying the delta with land that will make up for the compaction that occurs as the delta's sediments weigh on each other and they subside, as we say, or sink. On the seaside, we have the problem of eustatic sea level, and I'll explain a little bit what that means in a minute. And of course, I mentioned severe storms. Now, within all of this context, we have the coastal challenges that I've mentioned, the relative sea level problem, which is the rise of the sea in a relative sense is what we're most concerned with. And down here in Louisiana, it's a huge problem. We have eutrophication, the increase in nutrients that I mentioned. We have land use changes and all the nasty stuff that comes down the river. For example, we've got scientists now studying microplastics coming down the Mississippi River, trying to understand what that means when the plastics are imbibed by or eaten by the fish and shellfish down in the Gulf. And then, of course, general ecosystem changes. We have gradual global warming occurring right now, so that means we have more tropical species coming in. We have black mangroves now overwintering and surviving where they couldn't in the past, and that makes big changes. And then we have all kinds of demographic shifts that are occurring that we have to worry about. In Louisiana, we've actually lost population, but in Florida, they've got a population boom, and others, some of the other Gulf coastal states have a similar boom, like Texas, for example. So our coastal communities are very vulnerable, and I think that's an important point that we have to remember. About 40% of the world's population lives within 100 kilometers of the coast. That's a lot of people, and that means they're really susceptible to these coastal triple whammy threats that I mentioned. A large part of our nation's economic productivity, as I mentioned earlier, is located in coastal zones. And incidentally, all these are hot links, so you can get more information if you want from them. Sea level can really affect our infrastructure. And I don't think people think about it that much, but relatively small changes in sea level can affect drinking water, wastewater, stormwater utilities. And they can also introduce saltwater intrusions into groundwater and surface water. And obviously you don't want too much salt water in your fresh water or you won't have it to drink. It's been calculated that a 3-foot sea level rise, a meter sea level rise in essence, would result in a loss of wastewater treatment services for 8.4 million Americans. That would include places like New York City, where they're very vulnerable, and their sewerage is quite old, so it's vulnerable from that reason alone. And then, of course, if you live along the Gulf, you are always thinking about hurricanes. At least for 6 months of the year, you're thinking about them. And we're very concerned that storms are getting more frequent and stronger. And there is statistical evidence to suggest both of those things are occurring. So we're acutely aware of it in the last 2 years. There's no doubt about that. And it makes life very challenging. I will tell you, we had with Ida an extended period of time without electricity in Baton Rouge. With the storms that happened last year in the western part of our state, it was just a complete nightmare. And I have nothing but sympathy for the people in Cameron Parish and the other parts of Louisiana that were so badly affected last year. And I don't know how they can keep going. The devastation was so bad. Well, here's an old slide that I still keep using because it illustrates the point. This is from trends from back in 2007, 630 million people living in areas below 10 meters above sea level. That's a lot of people on a planet with approaching about 8 billion. 11 of the 15 of the world's largest cities with over 10 million are situated in that 10 meter above sea level area. 340 million people are living in urban areas below 10 meters. China alone has 143 million people living in areas of low elevation, and that's a significant fraction of the population. And the bottom line here is it's only gotten worse since. We have a very strong desire to live near the coast. Coast offers us lots of amenities. We can go to beaches, we can get seafood, all those sorts of things. And so there's been a trend to people living more and more in urban areas near coast, which puts them really at the barrel of the gun. And that's the problem. So let's talk about what we mean by sea level rise, because it's often confused. And I just saw, Kathy sent me a link to a CNN report that just came out talking about essentially coastal threats and vulnerability. And you would think that the only thing we need to worry about is what we call eustatic sea level, the rise of the sea due to global warming. In fact, we've had about 18 centimeters of eustatic sea level rise in our ocean over the last 100 years or more. And that's not that, something like that. It's not a huge amount of rise relative to some of the other problems that we've had. The real issue that concerns most of us in deltas is called isostatic subsidence, or subsidence, as some people will say. And it simply means that the land is compacting and sinking. And that is exacerbated by things such as withdrawing fluids from the sediments below the delta, such as oil and gas or water in some cases. So I put this little cartoon together to try to illustrate what we feel like in Louisiana. We're like this poor guy in the elevator going down when the water around the building is going up. So the elevator is representing the subsidence, and the water around the outside of the building is representing the eustatic sea level rise that we see. And I think that's a pretty fun way of looking at a not so nice problem. So let's talk a little bit about eustatic sea level. I already gave you a little bit of information. We know that climate changes. It always has, and it always will. So there is a significant signal of natural change in climate that we have always seen and will always see. But evidence is very strong that burning of fossil fuels and CO2 emissions and other greenhouse gases, such as methane, are exacerbating global warming that ultimately cause the sea to rise due to thermal expansion. Seawater is very interesting, and water is very interesting. It does not expand much when it's heated. But when you're dealing with an average depth of the ocean of 2 miles, you can see it, and that's how it's reflected. So the cause notwithstanding, whether it's atmospheric or not, there's a huge amount of evidence that eustatic sea level rise is occurring and will continue to be a factor into the future. But many people just do not realize that subsidence has been a much larger problem in the past, much, much larger. The flooding problems that we're seeing in New Orleans and on the Gulf relate to subsidence almost entirely. Now, it's predicted that will change, that balance will change in the future with accelerated CO2 induced warming. But for now, the real big problem is sediment starvation. Not enough sediments are going onto the delta to replace what we lose in vertical dimension through the capacity, through the compaction of sediments. And the bottom line for us, those of us who lived in the coast, we just have to adapt to these realities. And it's not easy. It's expensive. I mean, in our small state, which is a little over 4 million inhabitants, we have to take a significant chunk of our state budget just to deal with this sea level rise problem and the threats that our delta is facing. So that has to come off the top before we worry about healthcare and education and all the other things. Now, eustatic sea level rise, that is the rise of the sea itself, is depicted in this slide here, and you can see that it is accelerating. And if you add up the total changes since 1900, it's something between 150 or 200 millimeters, or 15 to 20 centimeters. And again, that's significant, it's important, but it does not account for the kinds of devastating coastal losses we've had in our wonderful deltas around the planet. And incidentally, I should mention that we have pretty good ways of estimating this. We have both satellite radar altimetry, which can provide very accurate depictions of how much the sea has risen. And I should, since I'm an oceanographer, I should mention that not everything is rising at the same rate. It's not 18 centimeters over the whole planet. Some places have higher, due to circulation issues, higher amounts of eustatic level rise than other places. So that's another factor that can complicate. So this is a little bit complicated slide, but I think I can explain you through it. Everything listed on this side of the graph, on the enough sediment side, is getting enough replenishment by sediment input to make up the difference from what they lose through the compaction and subsidence. If you fall below this line, then you're not getting enough sediment to keep up with the relative sea level rise that you're suffering. So there are a lot of really significant deltas listed in that section. Obviously, the Mississippi, the Mekong, you can't see it, but the number of Chinese deltas are also in that category, including the Yangtze, and just a whole bunch of places. So this is the real key. Rachel, you got it right when you said sediment is the problem. Sediment's a huge problem. Now, this is a very complex slide, and it's clickable, so you can actually look at it, and you can go around the world and find out what deltas are under what kind of threat. This was produced by a program that I was involved with for many years. It no longer exists as part of the IGBP program, which is now defunct. It was called LOEX, Land Ocean Interactions in the Coastal Zone. And they decided to do a nice, clear depiction of how the scope of this problem was really so huge around the world. Now, you can't see the slide on your monitors, and I know that. So I would encourage you to get a copy of the PowerPoint and click on it, and then just look at it carefully. I'm going to show you in the next slide a portion of this, just so you can get a feeling for one particular thing that I want you to know about. And that is, if you look at the left panel here, which says delta subsidence and shows the 20th century change, which is essentially what I showed you in that previous diagram or graph, that global sea level rise is about 18 centimeters. And that's that small blue arrow. But if you look at delta subsidence, it ranges between 80 and 400 centimeters. And that shows you the relative effect of subsidence. And the press gets this wrong all the time. And you'll now become acutely aware of it when you hear press reports, because they always want to associate the problem with CO2 and with global warming. And yes, as I said, CO2 is a problem, but for deltas, it's not the major problem. It's the sediment problem. So if there's one take home that you remember from this talk, it's that we have a serious problem with subsidence in our delta areas. In terms of delta risk, the Mississippi, if you look on the right panel, is in the greater risk category. There are three categories: substantial risk, greater risk, and severe risk. So we're not even the worst, we're not even the poster child of really bad delta situations. When you get down to this area here, you see the Nile, you see the Yellow River in China, which is really in trouble, the Yangtze River, which is in trouble because of the Three Gorges Dam, and I'll talk more about that in a minute, the Peril, etc. Our beloved Venice, Italy, we love so much, is in terribly bad shape, and they've got a project there to try to manage the storm surge and protect Venice, but how long that's going to be able to fight the sea is a really good question. So we're losing not only population centers, but culturally important areas such as Venice, and the Nile Delta is also, Rosetta is at risk. Lots of wonderful cultural heritage can be lost by what is being threatened in terms of these deltas. So it's really of concern. So what are some of the things that we do that alter the way our natural waters flow? Well, we're engineers. Humans are engineers, and this is not unique to Americans or any particular ethnic or cultural group or whatever. We love to build dams, levees, dikes, canals, etc. We have deforested a lot of land. Look at what's happening in Brazil. Look what happened in the colonial times in America. We pretty much deforested the whole Northeast, and we've had a resurgence there, and it's come back a bit, but we're now seeing it go in the other direction. We have irrigated and moved water around with canals and viaducts and things like that. We've constructed pavements and urbanized huge areas. And if you pave things, the water doesn't sink in and go to the groundwater. It runs off and can become a problem because it gets it's much more prone to cause flooding and things like that. Water control structures have actually tripled water residence time in impoundments on the land, and they've reduced water held in the upland sediments. So we're channeling water into impoundments, and it's not percolating down into the sediments and soils. The damming of the world's rivers is pervasive, with over 50,000 large dams now spanning the watersheds on 6 continents. And we've seen in our country what's happened with the Colorado River and damming, and that Delta is in trouble because of the Hoover Dam and the like. We've had dam problems in China. The damming of the Yangtze has created a lot of electricity, but it's caused real alterations in sediment delivery to the delta around Shanghai, and so on. So dams have been wonderful in terms of helping us deal with flooding and helping us generate electricity and things like that, but they've also had some really negative effects, particularly downstream on the deltaic areas. So humans now use about almost 20% of the global river volume for various activities. And reservoirs are now intercepting more than 40% of global river discharge. and maybe 1/3 of the sediments too, because a lot of the sediments that used to go to the coast are being intercepted in the dams, behind the dams. So a good example is the Aswan High Dam that was put in Egypt by the Russians back in the 60s. The Egyptians were promised cheap and abundant energy for years, and nobody thought about the potential of the sediments filling up the water behind the dam. And that, in fact, is what's happening is the sediments are accumulating so much that the useful life of that dam is going to be quite limited. So people don't think about that. They think about the immediate benefit. They don't think about the long term. And besides that, we as human beings are prone to think about what's going to happen in our lifetime and not be very prone to worry about what's going to happen in successive generations. And I want to just really emphasize that this is also global change. It's the death by 1,000 cuts metaphor. We have all these little indignities going on all over the planet. Dams being built everywhere, levees, dikes, etc. And they all cause changes in this hydrographic signal that we have, or hydrologic signal. And that's a significant problem for us. And we tend to, again, look to problems like the CO2 problem as the only problem, but the global effects of these small individual acts are substantial and ultimately result in global change. And my specialty is not, I'm not a geologist, so I'm really talking out of field here a little bit, but I'm a marine biologist who knows a lot about eutrophication, nutrient enrichment. And I know a lot about coral reefs, and we've seen a lot of degradation of coral reefs in time, primarily because there's so much nutrient material being added in the rivers that's now affecting coral reefs offshore. And so that's also a form of global change that we have to worry about. So let's keep moving here. I want to leave time for questions. So there's a World Delta database, and this is hot linked. You should be able to get to it. It lists about 75 deltas worldwide, and many of them are at risk. Of the 33 major deltas, 24 are sinking, and 85% have experienced severe flooding in recent years. So the large Amazon delta is in really pretty good shape, and that's a huge delta. But a lot of the large ones, besides that, are not doing well at all. Now, delta is a great place to locate cities, and more than 500 million people, 1 out of every 14 humans, or about 7% of the population in the world, live in deltas, like me, a delta guy. And many in strong and really big mega cities like Shanghai, Dhaka, and Bangkok. And they're a great risk. And again, it's almost as if the problems don't exist. We seem to have a feeling as humans that we can just keep constructing barriers to the sea's encroachment and solve the problem. But in fact, that doesn't work very well. And that's been proven time and time again through experience. But deltas are places typically with very rich soils, and they are excellent farmland areas. So their agricultural production is extremely important. If you look back in time at our wonderful Mississippi Delta, you realize that that is one of the factors that caused this rather hot and steamy part of the country to populate, as people recognized that it was a great place to grow things. Similarly, the Yellow River Delta in China would be another good example, except they've got a real water problem there. Deltas often provide good transportation access to inland areas. As I said, our Mississippi River is critically important for our export trade, particularly of agricultural foodstuffs and others, and other things to abroad. It's one of the areas where the U.S. balance of trade is positive. There are also areas for fossil fuel development, which certainly we've seen in Louisiana. Of course, that has its downsides as well, such as the withdrawal of fluids causing subsidence. So the Mississippi River has been channelized extensively. This picture on the far right here shows an aerial photo of what the birdfoot area of the Mississippi Delta looks like. This is essentially where the Mississippi River enters the Gulf. And you can see all the unnatural canals and things that have been put there. That is not helpful at all in dealing with the land loss problem that we're dealing with. And also, because we've so levied and channelized things, a lot of the sediments that would normally come and replenish the elevation we've lost to subsidence are simply shunted out to sea, and they're not useful to us. So not only are we seeing a diminution of the amount of sediment coming down the Mississippi, we're seeing that we're not even very effective at keeping that we have. So I'll talk a little bit about what we're trying to do to alter that. Now, as I said, the relative sea level rise as measured by tide gauges, which are very accurate, and there are long records for, show the different parts of the country and the different vulnerabilities. Where y'all are, it's relatively small sea level rise, relative sea level rise problem. But where we are, it's the highest in the country, 5 to 10 millimeters a year. And that is only a little bit every year, but over 100 years, that really comes out to be quite a bit. So that shows that we live in a real hotspot here. So I mentioned declining sediment loads in the lower Mississippi River. Before 1960, we had levels over 500 milligrams of sediment per liter. And then by the 60s and into the 90s, the loads fell to less than half of that. And this wonderful quote by Meade Allison and Ehab Misselli is that the 40 to 70% decline in the last half century has been attributed to the construction of dams on major tributaries, artificial levees, river straightening, wing dams, bank revetments, and soil conservation practices. Wing dams are the dams that don't go completely out, they just divert water flow. And that's what we're dealing with. So we're dealing with a diminution of the amount of sediment coming down the river, and then we're channeling the heck out of the river in addition to that. So if you look at the projections of 2009, when this paper was done, to the year 2100, you can get an aerial image of what the effect of this land loss will be. And you can see, for example, this big expanse of blue will be where all this land now exists. So we're losing massive amounts of coast. And we often hear the quote, we're losing a football field of land every day, or something like that. And it really amounts over time to be a massive amount. So our state, which is not known for a lot of advanced planning, happens to be doing a great job in terms of trying to plan for this change. We have a master plan that I think, a coastal master plan, that is as good as anybody has in the country. And I think we can all be very proud in Louisiana of that. And they're trying to find ways to mitigate the problems. So they're building flood control structures, although that's an imperfect way of doing it. They're trying to create fast lands with levees and marshes with dredging, which is always going on, for example, in the Mississippi. But most importantly, they're interested in developing river water diversions and sediment diversions. The idea being in high flow periods of the year, they would essentially channel the water coming down the Mississippi to flood into the marshes and wetlands and add sediment that would be lost compaction. And it's ambitious. And as you can imagine, it's controversial. People are saying, well, I don't want my house flooded. You're going to take away my land. People in the fishing industry say, well, you're going to be diverting all this fresh water. You're going to kill all my oysters, or you're going to cause the shrimp to go to a place I don't want them. Anyway, it's loud and can be very nasty sometimes. Our local congressman was almost run out of a room once, and he was scared by the angry crowd. But he was just trying to advocate that if we don't do something, we're going to lose it anyway. And so we've got to do something to avoid the land loss. Now, as you can imagine, we're talking a lot of money. We're talking $1 billion a year, at least in investment. That this poor state doesn't have a lot of billions to throw around. We have a very poor educational attainment. Our health statistics are not good, et cetera. So this is a real additional tax, if you will, on our poor part of the country. Now, slope is a very critical factor. A given rise in mean sea level will have a much greater effect when the slope of the shore is gradual. Sometimes it's referred to the angle of repose, but that would be well illustrated by the example below that shows a relatively steep coast versus the kind of coast we have in Louisiana. That means that a small vertical change is going to have a large horizontal dimensional effect. So if you live in Hawaii, where the shores are often very high above the water, sea level rise isn't going to have that much of an effect because it's not going to go inland very far. But if you live in a flat place like a delta, that exacerbates the problem. Simple concept, but I don't think a lot of people really think about how important it is. So I mentioned before the Yangtze and the Aswan High Dam, and this shows where the Yangtze Delta is replenished with sediments and nutrients in this watershed, and then Shanghai down here, a city with 20 million people or more. Here's the dam and what it looks like. It's the largest electric power generating facility in the world, had a huge cost. It's been completed for about a decade, and it generates a lot of really cheap electricity. And it's been great in that sense, and it's paid back its initial investment. The problem is the Chinese government guaranteed that it would not have environmental effects. Now, I don't want you to get in deep into this figure, but basically up top, the A is the before, and B, the bottom part, B, is the after. And the circled numbers show that there's been a real diminution of the amount of sediment load in these various parts of the river with time. Now, this particular paper was, a number of my scientists did in collaboration with people at East China Normal University in Shanghai. And the Chinese government was very forgiving and allowed this to be published because it's something that's pretty critical of Chinese policy. I don't know whether the current China, that kind of freedom exists as much, but you can't ignore the problem, and people are seeing it, and it's a real issue. And dams do have a huge effect. So let's talk about the Nile Delta, and I'm getting close to the end here. The prospects aren't encouraging there. Even a relatively modest mean sea level rise of 0.5 meter will cause a substantial amount. You can see it illustrated by these panels on the right. And a 1 meter would be absolutely devastating. And, you know, I don't know how they'll cope with it. For the people of Egypt, that's the breadbasket of Egypt. It's very important, and it's not doing very well. So I want to kind of end up with some relevant comments about where you live. You've probably all heard of the Cal-Fed Bay Delta program. It's a federal state partnership. I once did some consulting for the state of California in Sacramento on this program. And it's primarily a water project. And you are Californian, so you know that water is everything in California. And this will deliver drinking water to 25 million Californians, as well as feed the plants water in the Central Valley. So it's critically important. And the Delta loses out when this happens, especially with the kind of prolonged drought that you've been suffering. So there's some wonderful deltaic areas near San Francisco that are kind of wasting away. But the demand for fresh water it trumps everything else. So again, this is human beings channelizing the water. So what's the bottom line? I'll finish up soon. Deltas around the world are threatened by sea level rise, relative sea level rise. While global warming is of course a concern, the hydrologic cycle and sediment starvation of deltas is really important. Global change is not just global warming. It is much more than that. The Mississippi Delta is the signature delta in the US, and it has a huge challenge. And we have to ask, will future resources be sufficient to engineer our way out and protect our coast and restore? I think people in this state are realizing that the more we can use nature to help us, the better, and the less engineering we can do, the better. Now, obviously, political interests don't necessarily agree with that. There are engineering firms that have their livelihood based on how much they engineer in the Delta. So they're going to be quite naturally urging the legislature to fund more projects. So that's a big question for us. And that is it. And I will take questions. I hope I didn't confuse and I was pretty clear.
Thank you so much. That's great. Well, we have some people with questions ready to go. We have first Megan and then Luba. Let me allow everybody to unmute. And Megan, you should be able to unmute and ask your question.
Got it. Thank you so much. Thank you for your presentation. It was really informative. And I went to Tulane undergrad, so the Mississippi River holds a special place in my heart as well. But I guess my question was, you mentioned the problem has many causes, death by 1,000 cuts. If there was one or two solutions or efforts that we should, or that you'd want the most effort put behind, like, for example, would you want, everyone to take down their dams, or would you want to just stop extraction under deltas? Like, what do you think is the most important way to help the deltas?
Kathy really wanted me to put a slide in showing that, and I elected not to because I wanted to hear what you'd have to say and what you might think. That was a great question. I think that from my perspective is we want to return to natural as best we can. So we're going to need to have, particularly for our delta down here, much more natural sediment and water diversions, and much less channelization. And that's, as I said, it's going to be hard for real and not selfish political reasons. People are worried about their land and their livelihood, and they feel that threatens it. With regard to withdrawal of fluids, we've almost withdrawn all the oil and gas out of our land here, so it isn't much of a problem anymore for us. So that's not particularly a problem for our area. Other than that, I would urge the rest of the country to remember that poor states like Louisiana need some help. And with big talk about the infrastructure bill, we're not figuring in that infrastructure bill very much, and that's too bad, because whether people realize it or not, they're very dependent on Louisiana, simply because of the massive amount of maritime trade that we have. So don't forget us down here. That's what I would ask for.
Thank you.
Go ahead, Luba.
Okay. And yeah, thanks very much for that. And my question is really about where the money's come from, where the funding comes from for coastal restoration in Louisiana. And I thought there was quite a big BP oil spill payout that was set up to fund some of that work, and where that comes from. Although I did want you to also follow up a little more on what Megan asked, which is there any dam removal going on anywhere up the big Mississippi watershed?
Yes, there is. There's no question there's dam removal going on. And dams are not as trendy as they used to be. I happen to know a lot about the river estuary as well. And they've removed an awful lot of dams in the Hudson. Now, the Hudson doesn't have a delta associated with it, but it has a lot of fish migrations. And those are really impeded by dams. So yes, there's dam removal going on in our watershed. Whether it's enough to solve the problem is another question, because, as I said, unfortunately, we so channeled the river that the sediments that come down really don't get to the marsh and wetland areas the way we would like. They get shunted right out to sea. So that's a problem. The money's come, we get some money from the BP restoration, and that's helpful. We have our own tax burden that helps as well. And then there's some other federal funds that help. But it's a heavy lift for a small state.
Thank you.
Go ahead, Ben.
All right, thanks for a great presentation. That was really informative. Actually, I have two questions. One just came up when you said that Louisiana isn't being featured as much in the reconciliation bill. I didn't know that, and I was wondering if what you think the reasons behind that might be. Because when I think wetlands and deltas, Louisiana pops right up in my head. So, is it like a political thing that?
I think it's, well, my representative, who's a Republican, made that comment that he felt the bill was a disaster from Louisiana's point of view. And he's a Republican that actually works across the aisle pretty well. So if he said it, I think he's probably being quite honest about it. It's red state, blue state. That's all part of it. And people regard Louisiana as a bit of a backwater. It's not the first thought. Unlike Megan, who went to Tulane, most people don't know much about Louisiana.
Gotcha. Thank you. Yeah, that's good to know. And then my second question was more about your talk and just kind of your take on living coastlines, and what is their major benefit? Are they really useful at holding the sediment that is left there so it doesn't leave? And
Absolutely. Wetlands are critically important, and I'm really short in wetlands because I could have talked for an hour about wetlands alone. But if you do a core into our sediments, you'll eventually get to inorganic sediment as you go down deep. In other words, there's very little organic material because through time that organic material essentially is metabolized and burned off, actually goes out as CO2. But the wetland plants help to consolidate the marsh and help to keep what inorganic sediments come onto the marsh in place so that they can help build the marsh. But they're not sufficient by themselves to make up for the subsidence problem we have. So from my perspective, you need both the inorganic sediments and you need the growth of healthy marshes. And we have one scientist here who's a strong proponent of the idea that we need to reduce nutrients in the Mississippi because he thinks the nutrient levels are too high for marshland support. And he feels that we'd have healthier and better marshes if we were able to reduce nitrogen and phosphorus coming down the Mississippi. That's controversial. A lot of people don't agree with that. I'm not going to take a stand on it. I think we should be reducing nutrients for a lot of reasons.
Great, thank you. Appreciate it.
All right, Melanie, if you'd like to unmute and ask your question.
Thanks for the great talk. So the subsidence that was already human created from pulling out the fluids underneath Louisiana, that's a done deal. There's nothing you can do to raise that land back up, correct?
Not that I'm aware of. You know,
So,
we took a lot of oil and gas out from underneath, and it'd be almost impossible to pump it back in.
well, once the sediment settles, you can't like recreate that pore space that you lost.
No,
So the question is at this point, is it worth spending billions of dollars to try and shield us from the damage that we've already done there?
well, yes, it is, because if we can replenish sediments the way nature does by taking it from upstream and putting it over the land, that will counteract a lot of the loss we've suffered.
But wouldn't that just compensate for what's happening now? Like we can't kind of go backwards and extra compensate for the sediment that's already been removed from the Delta system.
Well,
Correct.
you're perhaps right about that, but I think, you know, the idea of buying time is something that we want to do. The longer we suffer from the very high rates of subsidence that we suffer from, the worse off we're going to be. So if we can forestall the loss of our Delta and New Orleans, maybe until other solutions can be developed, that's not a bad thing for us.
Thanks.
We're pretty close to 7, but Megan had one follow-up question if you're willing, and but we want to be respectful of your time, so let us know.
I'm not going anywhere. I'm glad to answer
Okay,
your question.
okay, go ahead, Megan. You'll be our final question.
And if anybody has any questions, just send me an email and I'll be glad to answer.
So kind of you. Thank you.
Thank you so much. I'll try to make my question quick. I was just thinking about, in your presentation at the beginning, you talked about the importance of the transportation and shipping in the oceans and rivers. And, you know, in order to maintain that importance in transportation, rivers have to be dredged. And I understand also ports have to be dredged too in order to make room for larger ships. But, you know, dredging has a big environmental impact. And so I was just wondering what your opinion was on that, and sort of balancing the economic importance, but then also the environmental aspect of it as well. And maybe there's no good answer, but I just wanted to get your take on it. Thank you.
Well, it is expensive to dredge and it uses a lot of energy to dredge. So those are two things that we're not thrilled with. But in order to maintain shipping, which is extremely important, we have to dredge. Now that the Panamax large ships are coming through, it's even a worse problem. In Louisiana, we're now starting to get creative about the dredge spoils. So we're using the dredge spoils to help replenish land. And so it becomes valuable that way. It's not just wasted or something we have to take out to sea and then dump and get rid of that way. So it has been beneficial to us in that sense. But I agree with you, it's terribly expensive. It can have negative effects. Our sediments are generally pretty clean in terms of toxicants. So unlike a lot of places where you might be dredging, say New York Harbor, where there is a lot of heavy metal or organic PCB and the like contaminants, we don't have that problem. So it's pretty safe to put the sediments on the land and you won't spoil the land.
Oh, thank you. And our, oh, go ahead, Megan, or somebody.
Oh, no, I was just saying thank you.
Okay.
Did I answer it? Good, okay.
Our participants, Luba and Melanie, were sharing some facts in the chat. Luba said, interesting fact, Shanghai has sunk 6 feet since 1920. And Melanie chimed in, the land surface subsided 12.7 feet in San Jose, California, due to compaction of fine grain compressible beds. So a lot of people knowledgeable here on the subsidence.
I'm impressed. The questions have been, to a person, excellent questions. They're thoughtful and they're the right questions, in my opinion. And so I'm thrilled.
So, hey, well, thanks, Chris, so much for the talk. I took a lot of notes here. Wetlands and kind of deltas and these areas are not areas of my expertise. So it's great to kind of get the good global overview. And again, I appreciate you, making yourself available to, follow up student questions. I'm sure there will be some.